Assalamualaikum students, welcome to lab 7 of Fundamentals of Programming course. In this lab we will be discussing about two-dimensional arrays. In the last lab we saw how we can do operations on one-dimensional data. The examples of one-dimensional data are the list of marks of students. The list of marks of students grow only in one direction, so they can be handled with the help of one-dimensional arrays. For example, the marks can be stored in an array that grows in only one direction. You might visualize it growing in this direction or this direction as you seem feasible. However, our data is not always growing in one dimensional. Sometimes we have the kind of data that grows in two different dimensions. For example, matrices. In mathematics, when we have a matrix, it can either grow in its columns or it can grow in its rows. So that kind of data can grow in two different dimensions. So we need a data structure that can handle that kind of data separately. For that we have two-dimensional arrays, where one of the things caters for the rows and the other caters for columns. In today's lab, we will be discussing about how to define and initialize two-dimensional arrays, how to take input in two-dimensional arrays, how to display the contents of two-dimensional arrays on the screen, and in the end, how to sum two different matrices using two-dimensional arrays. So let's start with our definition and initialization of two-dimensional array. We know that when we have to define and initialize a variable, single variable, we just need to write data type, then the name of the variable, and then the value that it is going to store. When we have one dimensional data, for example the list of marks of students, it can be handled using one dimensional array. And the way of defining and initializing one dimensional arrays is that similarly to the variable, we have the data type about how which type of data this array is going to hold. Second is the name of the array, and third is the size of the array, about meaning how many elements will be the part of this array. Here the size was 3, so we had 3 different elements in this array. And as there is only one index given in the definition, so it means that it is a one dimensional array that grows in only one dimension. You can visualize it as growing in this direction or growing in this direction. That's up to you. Next we have all different values written separated with the help of comma. A 1D array gets initialized and defined in such a way in the memory. Now moving on to the two-dimensional array, we have to cater for another dimension because the data is such that it can grow in two different directions. For example, the rows of the matrices can grow downwards, and the columns of the matrix can grow towards this side. So we have data that can be changed in two different dimensions. So we need to handle that data using two-dimensional arrays. And how do we do that? We first of all, we have the definition. In the definition we have the data type, about how what type of data this two-dimensional array is going to hold. Secondly, we had a name, just like we used to had in one-dimensional array. The difference comes here, as we need to handle two different dimensions, so we need to add two different indexes here that represents the size of two different dimensions separately. For example, here 3 was indicating the size in only one direction. However, there are two different indexes here. One caters for the rows and the other caters for the columns that are in our two-dimensional arrays. For example, here we define our data, our array, two-dimensional array, to be of 3 rows and 3 different rows and 4 different columns. And how did we initialize it? We made sets of the elements of each row. For example, the first row, whatever elements we want to initialize in the first row, we made one set out of those elements, place them in curly bracket, and then the second row elements had their own set, and third row elements had their own set. So all these were separated from each other with the help of commas. Then we had the closing bracket that incorporates all these sets within them and ended by a semicolon. Mm. So when we do this kind of thing, what it does at the back end in the memory is that it allocates such kind of data memory space in the memory that has three different rows interpreting from here and four different columns. Mm, and how do they get initialized? The first set of initialized values 1 2 3 4 get placed in the first row, next set of values get placed in the second row, and third set of values get placed in the third row. Now how will each element of the two-dimensional array will be accessed, and how can its data be manipulated? Just like we had in one-dimensional array, we had the data that could be accessed through one index. Here we will be needing two different indexes so that we can reach the particular row and a particular column where that value is stored. For example, the first, as we know that the arrays start from the index 0, so in mathematics our first element of the matrix is a11, second is a12, a13, a14. However, in arrays our first index is always 0, and so we will be calling the first row as row 0, second as row 1, and third as row 2. So we have three different rows, and we will be calling first column as column 0, second as column 1, third as column 2, and fourth as column 3. So any element we want to have the access of, we need to find at the where does it lie at the intersection of a row or a column. For example, first element lies at the intersection of row 0 and column 0, so it can be accessed using name 0 0. Name is the name of two-dimensional array, 0 is the 0th row, and 0 is the 0th column. Similarly, if we want to access any other element, we simply need to see where the row meets the column where it is present. So it is present at the intersection of row 0 and the column 1. It will be having, it can be accessed using a name of 0 1. Similarly, next element can be accessed using a name of 02, and next can be using name of 03. Mm. And you see that the last index is always n minus 1. For example, there were three rows, however we had row 2 as the last index because we started from 0. In programming, C++ arrays start from index 0. Similarly, we can access every single element. For example, we have to access 11. We can access this through its name and indices. Name of second row, it is in second row and second column. Similarly, name of second row and the third column. So that's how the data will be stored at the back end in the memory when we are talking about two-dimensional arrays. And the two-dimensional arrays can also be defined by just putting all the data within two curly brackets. What the compiler does is it breaks the data down into the number of rows it finds here placed here. For example, here were three different rows, so the data will be broken down into three different parts. For example, this and this, three different parts, and the compiler will place these values in the first row, these values in the second row, and these in the third row. That is how the definition and initialization is done in the 2D arrays. Now we look at how to display the contents that are stored in two-dimensional array onto the screen. When we have to display the contents of a variable onto the screen, what we used to do was just write cout name of the variable, and the data that was stored in that variable was displayed on the console. When we had a one-dimensional array, we needed one for loop so that our logic can be placed inside that for loop, and that for loop runs thus printing the values stored in one-dimensional array onto the screen. For example, here each element can be accessed through its index and a name. We started I with 0 because array start with 0. Firstly, it will print the value stored in name of 0, and name of 0 held the value 1. So on console we will 1 will be written, then it will go back, I will become 1 now, name of 1 holds the value 2, and that will be displayed on the console. Next it will go back, I will become 2 now, name of 2 holds the value 3, and 3 will be printed on the screen through cout, and after that I will become 3, this loop will get false and nothing will get executed. That is how we used to print the data of one dimensional array onto the screen. Now we have to print dimension the data of two dimensional array onto the screen. Here we needed to use a single for loop, and here we need to use two different for loops, outer for loop and an inner for loop, because we have to cater for two different things, the rows and the columns. Just like we studied in the nested for loops, that when we have two different loops, the outer one caters for the rows and the inner one caters for the columns. So we start running our loops. The outer loop runs from 0 to less than size, because the arrays start from 0 and go to size minus 1, and the size of rows was 3. So it runs from 0 to less than 3, and the column go from 0 to less than 4, because the columns were 4, they start from 0 and go up to 3. In the start, row will have the value 0, row variable will have the value 0, and the column 0 is less than 3 is a true statement will come coming inside this for loop. Column will become 0 now. Column will also have a 0 value. 0 is less than 4 is a true statement. We come inside the inner for loop as well. Here, just like in the one dimensional array, we used to write the name and a single index, because we had only one dimension that we were dealing with. Here we have to deal with two different dimensions, so we will be writing the name of the array and two different indexes where that data can be found. The first row had the value 0 and the column had the value 0. So any data present at name of 0 0, that is an index where row 0 and column 0 intersect, that will be printed on the screen. So 1 will be printed on the screen, then it will go back to this column will become plus plus. Now as you can see, rows value will remain same, because the outer for loop remains same and the inner for loop changes its values. A column will become 1 now. It will come back, row is still 0, column becomes 1. Any data that is present at 0 throw and the first column will get printed on the screen. 0 throw and first column used to have the data 2, it gets printed on the screen. Next it goes back, columns become 2 now. Column becomes 2, 2 is less than 4, name of row was still 0, name of 0, 2. That was row 0 throw and the second column in programming. So the data there was 3, so it gets printed on the screen through cout. It goes back, column becomes 3 now. Column becomes 3 now. 0 row, we are still in the row 0 and we are in the column 3, so any data present at name of 0 3 gets printed on the screen, that is 4. After that it goes back, column becomes 4 now, and as soon as column becomes 4, this loop gets broken, because 4 is less than 4 is a false statement. It skips these two brackets and comes here. Here it jumps on to the next line, on the console. Next it goes back here, row becomes plus plus, row becomes 1 now. 1 is less than 3 is a true statement. It goes in the inner for loop, column again becomes 0. Column is checked for 0 less than 4, that is a true statement. Now the data get printed on the row 1 and column 0 get printed. The row 1 and the column 0 had the data 5, and we are on the next line in console, so 5 gets printed. Similarly the inner for loop runs 6, 7, 8 and get printed. Then this inner for loop is broken, and we go on to the next line and go back. The row becomes 2 now. The column values again change from 0, 1, 2, 3, and 9, 10, 11, 12 get printed on the screen. You can see that we had a pattern. In the first row, the index of the row always remained 0. However, in the columns were always changing. Similarly, in the second row, rows, the index of row always remained 1, and the indexes of column were changing. So by observing that pattern, we made use of nested for loops in order to print the contents of two-dimensional array onto the screen. Similarly, if our dimensions increase, we need to apply another for loop, to display the contents of a 3D array maybe. Uh, that's how it works, and that's how we display the contents of two-dimensional array onto the screen. Now we see how we can take the input in two-dimensional array. Remember how we used to take the input in a single variable? We used to take input in a single variable by first defining that variable, so that some space in the memory gets allocated, so that if anything that is input by user can be stored at that particular address in the memory. For example, if we had to take input of the marks of one student, the variable was first defined so that it can hold the value that will be entered by the user later on. Similarly, when we had an array, we used to define an array and initialize it with 0 maybe. The definition was important because when the user inputs some data, it has to be stored somewhere. So it was defined in such a way that as the user inputs the value, for example, through this for loop, I is firstly 0, so the input will be taken at the array name of 0. For example, name of 0, for example, user enters 1, it gets stored here. The loop runs again with I updated to 1, so it prints 2 here. Next loop runs again with I updated to 2. Name of 2 now contains the value that was input by user in the address name of 2. So that's how we used to take input in a one-dimensional array. Now we see how to take input in a two-dimensional array. Of course, two for loops will be used to take input, two different to take input in a two-dimensional array, because we need to access the address of the row as well as of the column. Similarly, we run the loop again. In the start, row and column are both 0. So uh, uh, we are taking input in the place array name, and that was name of 00, and that means we are storing the data where the row 0 meets the column 0. So for example, user inputs 1, it gets stored here. Then loop runs again, columns become 1 now. Now we will be taking the input at a place array name. The row is 0 and column is 1, so 0 row and 1 column, they meet here, so the data will be stored here. Next it runs again, column becomes 2 now. 2 uh, 2 so we where we are taking input now is the place where the row 0 and the column 2 meet. Row 0 and column 2 meet here, data will be stored here. It runs again, the next data will be stored at name of 03. For example, user enter 4, it gets stored here. Next the column becomes 5, column becomes 5 now. 4 now. 4 less than 4 is the false statement, this loop gets skipped. We go back here, row becomes 1 now, and column again becomes 0. So now we will be taking input in the array of row 1 and column 0. So row 1 and column 0. So whatever user inputs gets stored here. Similarly, the inner for loop runs again and gets data stored here. Then it comes out of the inner for loop, row gets updated to 2. Any data that is entered by user will now get stored here. When the inner for loop skips, row will become 3 now. 3 less than 3 will become a false statement, and it will come out of both the for loops. Just building on the concept of how we take input in a variable, how we take input in a one-dimensional array, and how we take input in the elements of a two-dimensional array, we have established how we can take input in the elements of a two-dimensional array. Now we look at a small example of how we can sum two different matrices using two-dimensional arrays. Remember how we used to sum two different variables? We used to reserve a variable for storing our summation. For example, we had two variables a and b initialized to 6 and 8 respectively. When we had to do their summation, we first reserved a variable named sum and initialized it with maybe 0, so that when we sum it, the data can be overwritten and we have the correct result value 6 plus 8, that becomes 14. Similarly, when we have to add the corresponding elements of a one-dimensional array, what we used to do was we used to reserve one-dimensional array for our summation storage. Then we put our summation logic with the indexes into the for loop starting from 0 and ranging to size -1. What will happen here is that I will first be 0, so the array A from the index 0 will get submitted, summated on the array will get added onto the B of 0 element, the 0th element of the B array, and it will get stored in the 0th element of the sum array here. Secondly, it will go back, I will become 2 now, A of 2, I will become 1 now. A of 1 plus B of 1, the second element of A array and the second element of B array that were indexed through 1 indexes will get added and will get stored in the sum of one element of the array sum. Similarly, it will go back, I will become 2 now, A of 2 plus B of 2 will happen and summation of 2 will get stored in the sum of 2 element of the sum array. Now we have to add two matrices. The matrices are two-dimensional data. For example, we had to add a matrix 1, 2, 3, 4 and 5, 6, 7, 8. We had to add these two matrices. First, we'll store them in the form of two-dimensional data. How that will be done, as we saw that we will be defining two different matrices named A and B, and when they will be defined, they will be allocated memory in such a way that the first element has the index 0, 0, second 0, 1, and the next row has the indexes and can be accessed by 1, 0 and 1, 1. Similarly, with the P matrix, two-dimensional array will be handling this kind of data. Next, just as we used to reserve a summation variable here, it's just we used to reserve a summation array here. Here we will have to reserve a two-dimensional summation array for storing our summation value. Then we put our logic in the nested for loop, i.e. two different for loops inside each other. Now the row is 0 in the start and the column is also 0 in the start. So anything stored at the two-dimensional matrix A at the index 0, 0, i.e. this was our A matrix and this was our B matrix and this was our sum matrix. Two dimensions, some 2D array, B 2D array and A 2D array. A of 0, 0, i.e. A of 0, 0 will be containing the data 1, and that will be added to B of 0, 0 that will be containing the data 5, and those will be stored in the sum 2D array at the index 0, 0, i.e. this index, and the result will be 6 that will be stored here. Next, it will go back, column will become plus plus, column will now become 1. Column will now become 1, row is still 0, A of 0, 1, i.e. this element will get added to B of 0, 1, i.e. this element both will get added together and will be stored at sum of 0, 1. Sum of 0, 1. Sum of 0, 1 will contain the data 8 now. Next, it will go back, column will become 2 now. 2 is less than 2 is a false statement, these brackets will get skipped and it will come here. Here it will again encounter the closing bracket of another for loop, it will go back here, row will become 1 now. It will check 1 is less than 2 is a true statement, column will again become 0. column again becomes 0. So now we will be adding the data from A10 and A10 contain the data 3 plus B10 contain the data 7, and they will get stored in the sum10 of this address, and this will be containing the summation of these two. It will go back again, column will become 1 again, row is still 1, so a of 1 1, that is this element, plus b of 1 1, that is this element, will get added and get stored at sum of 1 1, that is this element, and the result at 12 will be stored at this particular address. So we just saw how we can extend our concept of summation of two variables and summation of corresponding elements of one dimensional array to the summation of two different matrices that will be handled through two dimensional arrays. So that's pretty much it from today's lab. In today's lab, we discussed how we can define and initialize a 2D array, how we can take input in it, how we can display the contents of a two-dimensional array onto the screen, and how we can add two matrices through the two-dimensional data structure, that is arrays. Thank you for joining in.